Hi everyone. Today, we'll talk about machine learning. Machine learning is an essential area of computer science. In fact, Bill Gates once said, "A breakthrough in machine learning would be worth 10 Microsofts." So, what is machine learning? It's the field of study that enables computers or machines to learn without being explicitly programmed. Think of the computer or machine here like children. Children are sent to schools. Their teachers teach them so that eventually they can read and write on their own without the help of anyone. To understand machine learning better, let's look at these examples. John and his friend are relaxing in Central Cafe, Brooklyn. After some time, they decide to go to Atlantic Terminal Mall as one of their friends is waiting there for them. They will travel by car. John checks the map and notices that the main route to the place has terrible traffic. However, the map suggests another route with less traffic, but will take a few minutes longer than the first one. John decides to use the second route and reaches the destination on time, as he has excellent driving skills. Have you ever wondered how a map works? Well, while we use the GPS every day, our current locations and velocities are being saved at a central server for managing traffic. The server uses this data to learn about the traffic and feed map users appropriate information about their routes. This was how the map was able to supply John the information about the two routes. Machine learning, in this case, helps to estimate the regions where congestion can be found based on daily experiences and learnings. Let's look at another example, which is the feature of people you may know on Facebook. Have you ever thought of how it works? Well, this is it. Facebook continuously notices the friends you connect with, the profiles you visit very often, your interests, workplace, groups you share with someone, and what have you. With well-defined algorithms, these data are then used to teach Facebook systems to understand your profile with experiences. Based on continuous learning, some Facebook users are suggested that you may know and become friends with. The main goal of machine learning is to predict results out of provided data. Now, let's talk about the components of machine learning. There are 3 components. The first one is the data. For example, if you want to forecast stocks, you will have to get data on the price history. If it's Facebook users' preferences you want, you'll collect data on user activities on the site. The more diverse the data, the better the results you'll get. Data can be gathered either manually or through automation. Those collected manually are usually time-consuming and can be very expensive, whereas the automatic approach is cheaper and less time-consuming. The data collected are also known as datasets. The second component of machine learning is features. Features are also called parameters or variables. Examples include the mileage of cars, stock prices, users' gender, and so on. The third component is the algorithms. Algorithms are the set of rules to be followed by the computers in performing their tasks. Problems can be solved differently. Solving them depends on the method you choose. The results are the outcome of the method. You must provide relevant data to get the best result. So keep in mind, if the data is useless, even the best algorithm will not give you any result. Please note that machine learning is different from artificial intelligence. Artificial intelligence is a broader field, while machine learning is only a part of artificial intelligence. Now, let's talk about the different types of machine learning. The first type, which is classical machine learning, is about statistics and solving math problems through patterns. There are 2 types of classical machine learning. They are supervised and unsupervised. Supervised learning is prevalent and easy to understand. It's similar to teaching your child using flashcards. In supervised learning, you feed a learning algorithm with some data in the form of examples with a label. The algorithm then tries to predict the label for more examples you provide. Over time, the algorithm will learn to recognize the exact nature of the relationship between examples and their labels. It will then be able to observe a new, never-before-seen example and predict a good label for it. Typical scenarios where supervised learning is used include the face recognition system and classification of spam messages. Unsupervised learning is the opposite of supervised learning. Here, there are no labels. The algorithm is fed with a lot of data and given the tools to understand their properties. The algorithm then learns to organize the data sensibly. There are 3 types of unsupervised learning. The first one is called clustering. Here, the machine divides the objects based on unknown features. Clustering is mainly used for market segmentation, merging close points in the map, detecting abnormal behavior, and so on. Popular algorithms used in clustering are mean shift, k-means clustering, and dbScan. The second type is dimensionality reduction, which is also known as generalization. This type assembles specific features into more high-level ones. It is commonly used for fake image analysis and risk management. Popular algorithms used in generalization are principal component analysis, singular value decomposition, latent Dirichlet allocation, and latent semantic analysis. The third type is association rule learning. This type is used for forecasting sales and discounts, analyzing goods bought together, or web surfing patterns. Popular algorithms used in association rule learning are a priori, ECLAT, and FP growth. As you could have predicted, the machine will learn faster with supervised learning than unsupervised. Now, let's discuss the second type of machine learning, which is reinforcement learning. Reinforcement learning is all about learning from a mistake. This is how it works. The reinforcement learning algorithm is exposed to an environment where it trains itself continually using trial and error. It then learns from past experiences. Over time, the algorithm learns to make fewer mistakes and capture the best possible knowledge to make accurate decisions. Reinforcement learning is mainly used for self-driving cars, automating trading, enterprise resource management, and so on. It is used in cases when your problem is not related to data at all, but you have an environment to live in just like a video game world or a city for self-driving cars. Let's now discuss the third type of machine learning, which is the ensemble method. In this method, you basically throw a bunch of inefficient algorithms and force them to correct each other's errors. This type of machine learning gives you better results. The eventual overall quality of a system will be higher than that of even the best individual algorithms. Popular algorithms used in the ensemble method are random forest and gradient boosting. The fourth and the last type of machine learning is neural networks and deep learning. Neural networks involve a set of algorithms which are modeled loosely after the human brain to recognize patterns. This type of machine learning is generally used for replacing all the algorithms mentioned earlier. They are used in identifying objects on photos, videos, speech recognition, image processing, and so on. Popular architectures used in this are perceptron, convolutional network, recurrent networks, and autoencoders. That's all about Introduction to Machine Learning. I hope this video has helped you to know something about machine learning. If you are interested in learning more on machine learning, you can check the link in the description box below. Thanks for watching.